Okay, so here's the next thing that we've got. We've got the same sort of differential equation, but instead of equaling 0, we've got a function on this side, 10e to the 2x. So the first thing we do, we want to find the general solution. So basically that's just y double dash plus 4y equals 0. So we consider that first. And I've kept it fairly simple here just so we can get to the next part as quickly as possible. How would we solve this? Lambda squared plus 4 equals 0. So lambda squared equals minus 4. So lambda equals plus or minus 2i. So it's one of those complex numbers. So our general solution, y general, is going to be sine 2x plus cos 2x. Remember, there isn't any real part. If there was a real part here of 4, then it'd be e to the 4x sine 2x plus e to the 4x cos 2x, but this is 0, so I've just left that as 0. So that's the first part. And then we look at the next part, and that is the fact that y double dash plus 4y equals 10e to the 2x. So again, what we end up doing is this specific solution, the specific solution is going to have to come out to be this. So we have this educated guess that we consider that y might be some ae to the 2x. We don't know what a is, but we know if we start differentiating, this thing isn't going to change. So what we know is that y dash is going to be 2ae to the 2x. We know that y double dash is going to be 4ae to the 2x. So there are our little equations, and then we just start substituting them into our original one. So what we've got is that y double dash 4ae to the 2x plus 4 times y, so plus 4ae to the 2x. We know that is going to equal 10e to the 2x. Okay, and what we've got there is we've got, well, we can divide everything by e to the 2x, and what we get is that 8a equals 10. So a is going to be 5 over 4, 10 over 8 or 5 over 4. And that's our next next part of the solution. So our final solution is going to be y equals sine 2x plus cos 2x plus the specific solution here, or the solution here, where a equals 5 over 4. So that's going to be 5 over 4 e to the 2x. Sorry, there should be some C1 plus C2 here. C1 plus C2. Because we haven't got initial conditions for these ones, so we don't know what they are yet. This is like a constant, perhaps, or something like that. Initial conditions we will use to solve C1 and C2. This is a specific solution. So when there is something on this side and it's an inhomogeneous, this would be a homogeneous because it equals 0. This is inhomogeneous because there's some function over this side. Then we consider it to be a homogeneous, find a general solution here, and then the specific solution for this part. And again, if this had been sine x or something, if this had been in the form of sine x, then that would have been your form here, something a cos x plus b sine x, and we'll find for solve for a and b. Okay.